Alright, Crewton Ramone's houseofmath.com using Screencast-O-Matic. I just bought the Pro version for $9. It's crazy what you can get for $9. That's an unsolicited and uncompensated, by the way, endorsement. This is cool software right here. Use it with the Pro version. You get motion video, and later on you're going to see over here I'm going to have a inset screen, and oh man, you can just do all kinds of stuff. And some basic editing software comes along with it for $9. You can't beat it. Okay, let's get into it. And that'll probably be the last time you hear a long endorsement for Screencast-O-Matic here, but I just got to give those guys kudos because they've done a fantastic job, made a great tool for educators and anybody that wants to do screencast math web seminars. I could go 60 minutes on this, and I will be doing 60-minute videos later on, but of course YouTube limits us to 15 minutes, so let's get going. I've already spent a minute. X squared, 8x, and 16 right out of the get-go. First thing out of the chute. We didn't do add-ins, we didn't do any rate, we just said let's do algebra, and she likes doing algebra. It's fun. This is a 17-year-old autistic child, very functionally autistic, but still very childlike. I would put her, mental age well below 10, but doesn't mean she can't do math, doesn't mean she can't get concepts here, and it's making it fast, easy, and fun to do algebra. And with the algebra we will teach base 10 mathematics, and with the base 10 mathematics we will teach algebra, cross teaching, right? Okay, so there it is, x squared, 8x, and 16. She whipped this together in mere seconds, literally, and she's counting one side as x plus 4 and the upside is x plus 4, and you see that we get x plus 4 squared. Simple. And she understands now, because we've done this before if you've been watching the videos, that we talk about economy of symbol and why we just write x plus 4. We don't have to write it twice. We can just use that symbol right there to say that it's x plus 4 two ways. X plus 4 times itself. Now with the little kids, again, she's past this stage, but with little kids, you would have them getting out. Oh, now we've moved. It's the same blocks, basically the same set of blocks, but now we've made it 12x and 36. So now they have to be able to tell that, oh, they need 4 more. Right? The very simple method. And then 36, making a bigger square. And we can talk about building square numbers and so forth. Then here we have FOIL, so we can show partial products. FOIL, by the way, is shorthand for frustration in algebra. Most students find this difficult and doesn't make it fun or easy because they only see the symbols. But here we can see the partial products very clearly. And there's my x square, right? X times x. There's my 6x. There's that, right? The rainbows, as one little child used to say. And here is 6x, right? 6 times x, there it is. And 6 times 6, 36. There they are, all 4 parts, which is why we call them quadratics, by the way. Let's see. And there it is close up, so you can see what's going on. But see, if you only had the symbols, it's not helpful, right? If you only have this in a picture, still doesn't make it really clear, guys. Seriously, the manipulatives get all the students. Right? It makes it much easier and much faster. No questions asked. Okay. There is the next one. Ooh, that looks scary. X squared, 14x, and 49. Look at that. Oh, but no, it's not. It's that. It's just that. Simple. And again, this got whipped together in seconds. Now, what if we go back? We go back to base 10. We flip the blocks over. Now remember, they were on the smooth side before. This was an x squared, and these were x. But now it's on the rough side. Remember, algebra is not a rough subject. It's a smooth subject. Here I can see that this is 100. These are 10s. And these are 40 and 40, which gives me 80. And there's my 16. Oh, 14 squared. 196. Excuse me, 196 to be proper. And there's move up 1, 2. See, suspiciously looking like x plus 5. But it's 10 plus 5 now, and we had 10 plus 5 squared, which is what that is. There's expanded notation. And there we expanded even more. And I didn't take a picture of the work, what we did down there, but there's my 10 times 10, 100. There's 10 times, there's 10 times 5. There's 5 times 10. There's 5 times 5. Add them all together, you get 225. Completely easy to understand. And there's, you just saw, the same as x plus 7. Now, again, I didn't talk about evaluating and x being all kind of different things, and we're just doing base 10 and base x. And that was it. Having fun and understanding what's going on here. How I got 100, why that's 140, and why that's 49, and adding them up and making it easy. And also, some of you may see the rule. There's a trick I saw in a couple of videos and other places where they talk about the trick is this, and look at the 2 times the and the 4. Like I said, if you let the kids learn this way, they will tell you the rule. They will discover the rule for themselves. Completely different than you giving them the rule. Oh, here's a quick way to memorize and do this kind of, because then they'll forget it. But if they discover it, it's theirs. Huge difference. All right, so now let's move down technically, right? We're going to be just 7 times 17. So 7 17s, or excuse me, 7 taken 17 times. What do we have? She's counting it out right there. And we see we have 70 plus 49. Right? That's 119. And then we do base x. And oh, it turns out it really is easier, right? Because here I have to combine. Over here I can't combine because they're not same kind. I can only add stuff that's same. Go over the 5 basic concepts. And do you see here, we form rectangles, facilitate counting. Right? Go right over those 5 concepts very quickly and easily. It's always the same. Doesn't matter what we're doing. Algebra, calculus, pre-calculus, fractions. It's always those same 5 concepts. Okay, 7 19 times 133. It's just 70 and 63. And then we can see a little bit more. Another way to look at that would be 140 minus 7. Because there it is, really. See that there's 70? It isn't 63, just 70 minus 7. And there it is, showing this the 70 if this was 10s instead of 9s. And I've spent a lot of time talking about what, how to attack this and how 70 and 63 really is the same thing as 140 minus 7. Because you look at these symbols and they don't look same to little kids. And it's amazing to them that this and this is the same as this and this. And it adds up to 143, or in this place, when we combine these guys, we get 133, and when we combine these guys, we get 133. And they're both the same as 7 times 19. Okay, and then there's the algebra, right, using base x. Right. 7 taken x plus 9 times. We get 63, and we don't know how many, because this could be 10, looks like 10, but could be 5, could be 3, could be 7, could be square root, could be something, we don't know. Alright, and then getting bigger again, 19 11 times. So we just so happen to start playing with 19s. And do you see, there it is, 190 and 19 gives you 209. And then look at all the, we've got all these 19s in reserve here, and we're just going to get bigger, and I'm not going to cover every single one of these, but you can see that we just get bigger and bigger, and bigger is funner. There is the solution to that one. And what we have here is 190 plus this 38. Do you see how we start combining the problems and you're just getting bigger and funner? We've already done these kind, and now we're just adding this much. And there's a reason for doing it this way instead of doing cross multiplication and doing the partial products and putting them together. Because here I have 190 and here I have 38. There's a reason for that. We'll see this as we do division a little bit later. And now we've done 14 times, and we had to do a little bit of work because she looked at 4 times 19, which is this right here, and couldn't remember what it was off the top of her head, so she quickly just did 40 and 36, and now we see it's 190 plus 76 because it's 266. Simple, easy, fun, and taking a look now. Oh, look, the only thing that's changing is this. Right? It's still going to be 19 across every time, and then we're just going to change how many. So it's going to be 190 plus some more every time. Okay, so now when it's 15, it's 190 plus 95. Very simple. And then we did the cross multiplication down here. So really there's multiple ways to do any problem. And what's the best way? The way you like best. And in this one, I'm just showing her this because later on we're going to be doing some division. And now we change in the base x plus 9 to, and you see, same block, same manipulatives, and we can see there is my x squared. There is my 9x, there's my 5x, there's my 45. Put it all together and you get x squared, 14x, and 45. And the reason why children like to do this, and it's a reward and it's fun, is because it's easier. It really is, because I don't have to do all the combining. I have this kind, and this kind. The only combining I have to do is adding the x's together. It's always simple because they're small numbers. and never have my add-ins again. Anyway, add-ins past 10. Okay, so x plus 9, x plus 8, easy, super fast. Whipped it together, counted it all up, and there's the answer. Okay, and again, put that together super fast too, and there it is. You're starting to count it and figure out x plus 9 squared is the same thing as x squared, 18x, and 81. There's my 9x, there's my other 9x, there's my 81, there's my x squared. Super easy, they understand it. It makes it simple and fun. Okay, and then 19 squared. Oh no, 19 squared. Well, that's still pretty easy, right? Because it's just the same thing as we just did, except now we have to do all the combining. And again, you can see the rules that sometimes they'll give you for squaring numbers about the 100. Oh, how to get 18? That's like 2 times 7. Ah, very simple and easy. Now, down here, right, adding these together, and then you get the same answer, but we're doing it using cross multiplication. And watch the videos on cross multiplication. I made 2 of them. And you can see there's my 9 times 9, there's my 81. See, it's split up there. And then there's 9 tens and 9 more tens. 9 tens and 9 more tens. Plus that 8 gives me the, right? So there's that, right? And that makes it another 100. So I had tens hiding with my units. I had hundreds hiding with my tens. And I add them all up together, and I get 1, 2, 361. Anyway, watch the cross multiplication video and you'll see more. This is actually a pretty advanced problem for cross multiplication, but we've been playing with it, so for her it was easy and fun. And see how much more understanding you get than just this matrix, because I told her, look, I want you to know your numbers all the way from 20 to 20, not just 9 times 9 or 12 times 12. I want you to know the whole thing out 20 times. So she got this and was using it, and it was becoming a little frustrating. And memorizing it wasn't easy, and so we just started playing with numbers and blocks, and wow, it was a lot easier that way. So now, as promised, some division, and I didn't flip them over. You won't be able to see the algebra here, because we just did this, and then I ran out of batteries and film and everything. So anyway, 19 across, right? The whole thing is 361. How far is it down? Well, now do you see the 190? Oh, and there it is down here, right? 171. Oh, done. That's it, right? Now, I do not recommend trying to do every single problem in division with blocks. It's not the idea. The idea is to understand that what you're doing is basically just subtracting, right? The division is just multiplication and subtraction, or just subtracting out here, but getting to see the patterning and how it works, and how fun, fast, easy that is. Right? It's just no problem, literally. Okay, so now let's make it smaller. Right? We stretched, and actually we're going back down now. So I have 228 in the rectangle. There it is. One side's 19, right? She has to tell me the other side. Well, if this side's 19, this side's 12. That's easy. But let's show our work. So do you see? Oh, there's the 19 times 10. Right? So there's my 190. And some people just put an arrow here. It's just like 1 times 9. No, it's 190. It's really what you're doing. It's 10 19s. You're not taking 19 away from 22. Because that's exactly not what's going on here. What's going on here is you're taking 190 out of 228. Alright, so then, what's left down here? Well, my 2 19s. Right? So, I multiply 19 times 2, and you'll see it here in a second. Let's go further. There you go, 38. Oh, we didn't do it in steps. I didn't get pictures of it in steps. But there is, right? And again, this right here, what is she doing? She was figuring out how much this was, right? So there's 38, and what that is really when we subtract 228 minus 190, you leave 38. And then I multiply 2 times 19. There it is, done. And there you have it. A simple lesson on multiplication, division, showing how they're inverse functions, the algebra, base 10 mathematics, right? Multiplication past 10, all in one simple, fast, easy lesson. And they can see how the math goes together, and it's not a meaningless dance. It all goes together nicely, easily. You see what you're doing, makes it fun. Crewton Ramone's houseofmath.com for more.